My name is P. Chandrasekhar from second year mechanical. Today I am here to talk about the brief introduction about characteristics curves. It is related to the fluid mechanics and hydraulic mission subject. Now we are entering into the content. Content beyond this PPT is introduction to characteristics curves and types of curves, advantages, disadvantages and examples references. These all are the we are going to know in this PPT. Introduction to characteristic curves. Characteristic curves are graphical representation used in various fields such as engineering, physics, and statistics. They illustrate the relationship between two variables, often highlighting performance or behavior under different conditions. Understanding these curves is essential for analyzing system performances and optimizing designs. Understanding of characteristic curves is used to analyzing the performance of system and optimizing the designs. Definition of characteristic curves. A characteristic curve is a plot that depicts the response of a system to varying input conditions. These curves provide insights into system behavior, efficiency, and performance metrics. They can be derived from empirical data or theoretical models depending on the application. Types of characteristic curves. Different types of characteristic curves exist, such as linear, exponential, and logarithmic. Each type serves specific purpose and is suited for different types of data analysis. Understanding the type of curve is crucial for accurate interpretations and applications. Importance of characteristic curves. Characteristic curves are vital for visualizing complex relationships in data. They help engineers and scientists make informed decisions based on empirical evidence. These curves also facilitate comparison between different systems or processes. Applications in engineering. In engineering, characteristic curves are used to evaluate performance of machines and systems. They aid in understanding the efficiency of engines, pumps, and turbines under varying loads. Engineers utilize these curves for design optimization and troubleshooting. Applications of electronics. In electronics, characteristic curves illustrate the behavior of components like diodes and transistors. They show how voltage the current relate under different conditions, guiding circuit design. These curves are essential for redirecting component performance and reliability. These are the applications of characteristic curves in electronics. Mathematical representation. Characteristic curves can often be described using mathematical equations. These equations define the relationship between input and output variables. Understanding these equations allows for precise predictions and modeling. Deriving characteristic curves. Characteristic curves can be derived from experimental data through regression analysis. Statistical methods help in fitting a model to the observed data points. This process ensures that the curve accurately reflects the underlying relationship. Interpreting characteristic curves. Interpreting characteristic curves involves understanding key features such as slope and intercept. This slope indicates the rate of change while the intercept provides baseline information. These features helps in assessing the system and behavior. Limitations of characteristic curves. Despite their usefulness, characteristic curves have limitations, such as oversimplification of complex systems. They may not account for all variables influencing system performance. Careful consideration is necessary when applying these curves to real-world scenarios. Pump performance of curves. Examples. Pump performance curves illustrate the relationship between flow rate and head pressure. These curves help engineers select the right pump for specific applications. They provide insights into efficiency and operational limits under varying conditions. Battery discharge curves. Battery discharge curves show how voltage changes with the time as battery is used. This curve helps understanding battery life and performance under different loads. They are crucial for designing battery management systems in various applications. Examples: how flow characteristic in fluid dynamics. Characteristic curves in fluid dynamics illustrates the relationship between flow rate and pressure drop. These curves are essential for designing piping systems and understanding fluid behavior. They help pre-direct performance and optimize systems layout. Comparing multiple characteristic curves. Comparing multiple characteristic curves can reveal difference in performance among various systems. This analysis helps in selecting the most efficient or suitable option for a given application. Visual comparison aids in quick assessments and decision-making processes. Tools for analyzing characteristic curves available for modeling and analyzing characteristic curves. These tools can automate data processing, regression, and analysis curve fitting. Utilizing these tools enhances accuracy and efficiency in analysis. Case study: automotive performance. Characteristic curves are widely used in automotive industries to assess the engine performance. These curves help in tuning engines for optimal power and fuel efficiency. They also assist in compliance testing with environmental regulations. Future trends in characteristic curves. Advances in data analytics and machine learning are enhancing the analysis of characteristic curves. These technologies allow for more precise modeling and prediction of system behavior. Future developments may lead to more specific and dynamic characteristic curves applications. Conclusion: characteristic curves are essential tools for understanding and optimizing system performances. They provide valuable insights across various fields from engineering to electronics. Mastery of characteristic curves enables better design and operational efficiency. For better understanding about the characteristic curves, you have to refer this N. Modi and S. Mehta, Hydraulic and Fluid Mechanics, including Hydraulic Machines, Standard Book House, 22nd, 2019, and Dr. R.K. Bansal, a textbook of Fluid Mechanics and Hydraulic Machines, Lakshmi Publications Private Limited, 10th edition, 2019. Thank you for giving this opportunity.